Hey guys, this is the second day of our surface area and volume unit. Today we're going to talk about surface area. You should have already completed the warm-up that classified prisms and pyramids, cylinders, spheres, all that kind of stuff. So if you haven't done that, please go to Microsoft Forms and complete that. Okay, so looking at what we're doing today, I've already got some stuff up here. The first thing I want to talk about are rectangular prisms or cubes. Here's the surface area formula. Okay, so it's 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. So basically, all this is saying is that you got to find the area of each surface of this shape and add all the areas together. And that's really all it's saying. So if you look at this one, number 1 right here, it has this one labeled right here. That is a rectangle. So it doesn't matter which one you pick for the width and the length of this rectangle. Now the height is just going to be the distance between what you pick for the two bases on this rectangular prism. Okay, so our height here is going to be 9. So basically what you're doing is you're finding the area of this rectangle, then you're going to multiply it by 2 to get so that you can count for this rectangle. This rectangles are the same. That's this first one. All right. And then the second part of this, you're going to do the length times the height. Okay, so, I mean, you can look at this a couple different ways. You can do this rectangle, which is basically what it is, 7 by 9 here. Okay, that would be these two rectangles on the side. And you're going to add it to the area of the two front and back rectangles, which here it says 2 times W times H. So this would be 13 times 9, and then multiply by 2 to get the second one back here. So basically the process of finding the surface area is just finding the area of each surface of the shape and then adding all those areas together. I know that it looks like there's like a lot of complicated formulas. We're going to break some of them down, but really all it's doing is giving you a shortcut for some of these. All right, so let's look at number 1. Okay, so looking at this one, we're just going to fill in here. Okay, so we have 2, I have the formula written down already. So we have 2 times the length and width, so we're just going to put 7 and 13. We're going to use that bottom rectangle, plus 2 times the length and height. So I'm just going to use 7 times the height between the two right here is 9. So 7 times 9, plus 2 times the width. I've already used 7 here. So for the width here, I'm going to use 13, and then the height again is 9. So 2 times 13 times 9. All right. And then when you get that, you should get that one of those sets of pairs of rectangles is 182, one is 126, and one is 234. So those are your 3 pairs of sides for this shape. Okay, add all those together, and you're going to get 542 square feet. I obviously could have skipped this step right here. I was just trying to show you what each one of those were. Okay, so that is my answer, 542 square feet. That is the surface area of that rectangular prism. All right, pause the video here and y'all do number 2 and then check back to see if you got your answer correct. Okay, so all you have to do again is just plug in your numbers. All right, so I'm going to use 11 by 6 for my base here, the one that's the big one on the bottom. I could have just done this little side one. It would have been fine too. Okay, so you have 2 times 11 times 6 plus 2 times 11 times 1.5 plus 2 times 6 times 1.5. Okay, and that means that you should get this one right here would have been 132 square feet. This one would have been 33 square feet. And these two together would have been 18 square feet. And you add all 3 of those together, you get 183 square inches. I was saying feet, but they were inches, sorry. All right, so 183 square inches. All right, let's look at all other prisms. Okay, so for all other prisms, it says first find the lateral area. Well, the lateral area is just the height times the perimeter of the base here. All right, which is what's in your surface area formula. Okay. Then add the area of the bases. That's really all you're doing. So 2 times the area of the bases. So this height right here is the height between the bases. So it's the distance between the two bases. So for right here, number 1, your two bases, I have them highlighted. They're 2 triangles. Actually, I should have highlighted that part. I'm so sorry. So there are two triangles, and this. There we go. All right, so it's two triangles, front and back. Now, the height of that triangle is 4.1. Okay, but the distance between the two triangles you see is 3. All right, so the bases are triangles, so the area for that is going to be 1/2 base times height. That's what's going to get right here. The h is the distance between the two, which is 3. And p is the perimeter of the base. So you're just going to add the perimeter of the base here, which is 5 plus 12 plus 10. 5 plus 12 plus 10, which is 27. Okay, so I'm just going to fill in here. Okay, so my pen to work. All right, so we have the height, which we just said was 3. All right, the perimeter is 5 plus 12 plus 10, which is 27. And the area of the base, to find that, is 1/2 base times height. So this is going to be 1/2. Well, it's going to be 1/2 times your height of this triangle is 4.1. And the base is 12. I guess I could have switched that around because that's not how we normally write it. And so your base is 12 and your height is 4.1. Okay, so plug that into your calculator and you get 130.2 square kilometers. Okay. Okay, so let's talk about the process of this. So basically the lateral area is just this, it's the same thing as finding the area of the 3 other sides of the prism and adding them together. Okay, so basically that's all lateral area is. It's finding the area of the other parts of the prism that are not the base and adding them together. So this h times p is just a shortcut for that. All right, y'all pause the video for number 2 and work that one out, and then check your answer. Okay, so for this one, your bases are trapezoids. So the formula for the area of a trapezoid, remember, is 1/2 times the height times the sum of the bases. Okay, so I'm just going to fill this in over here. I've got the formula written down already. So we have the surface area is equal to h, which remember is the distance between the two bases. So for here, that would be 15. All right, times the perimeter of the base. So looking at this, we have 12 plus 23 plus 20 plus 18, which gives us 73. So the perimeter is 73 plus 2 times the area of the base. So remember the formula for the area of the base is what we wrote up there. It's 1/2 times the height of the base, which here, remember the height and the base form a, the height and base of your base figure form a right angle. So the height is 12. Okay, so the height is 12, and your two bases of your trapezoid are 18 and 23. So you add those together. My pen does not want to work. I don't know why. Okay. All right, so when you fill that in, you get this part right here. 15 times 73 is 1,095 plus 2 times 246. So the area of one of those trapezoids was 246 square feet. So put this in your calculator, and you probably already did this part, but I just want to make sure I broke it down for y'all. Okay, so you get 1,587 square feet, which is the surface area of that figure. Okay, so what I want y'all to remember about lateral area, it is the surface area without the bases. So it's the area of the surface area of the figure without the base or bases. Okay, let's go to the second page. All right, now we're going to talk about cylinders. And I did highlight the bases for these. The bases of a cylinder are circles. Your lateral area is 2 times pi times radius times the height. All right, your surface area formula is basically the area of the two circles, 2 times pi r squared, plus the area of all of this part right here, right, which was your lateral area. H is the distance between the two bases, okay? So right here, I say read last page of notes. I want to talk about this formula, break it out a little bit. So it is 2 times pi r squared. Pi r squared is the area formula of a circle, okay? So, and there's 2 circles here, so it's 2 times the area of one of the circles, so you get both of them, plus the lateral area, which is this part right here. It says read the last page of notes, so let's go look at that. Okay, so looking at this, whoops. Okay, surface area process for cylinders. So basically, this is still finding the area of the other side and adding it to the area of the two bases. So it's like wrapping a rectangle around a tube. You have the height, but you need the width, and the width has been wrapped around a circle. So the width is the same as the circumference of a circle, which is 2 pi r. All right, so look at this. So here you have your rectangle. The height of that cylinder, which is the height of our rectangle, so it's the length, is going to be 26. The width, which is 2 pi r, because that's the part wrapped around the circle. The formula for the area of a rectangle is length times width. So it's this, your height, times the width, which is 2 pi r. So that's what it is right here, 2 pi r times the height. Okay, so let's go back and look at where we were. And we were right here. All right, so let's go ahead and fill this in. Okay, so we have the surface area equals, we need to fill in this too. Make sure you use the pi button on your calculator. So the radius here is 11. All right, I'm just going to fill the rest of this in again. The radius is 11. The distance between the two bases is 26. Okay, so before you use the pi button on your calculator, I want to get this in terms of pi. So I'm going to treat pi like a variable and just leave it alone for a second. So I'm going to say 2 times 11 squared, which is 242. So I'm going to get 242 pi plus 2 times 11 times 26, which gives you 572 pi. Okay, that right there gives you 814 pi. Okay, so that is 814 pi. So if I ever ask you to give the answer in terms of pi, this is what I mean. It means don't evaluate pi, just give it like this. This is actually the most accurate answer. Okay, so now let's go ahead and evaluate it using pi. So in your calculator, type in 814 times pi using the pi button. When you do, your approximate answer is going to be 2,557.26 square yards. Okay, you'll pause the video and you work number 2 and then check back on your answer. Okay, so for this one, I gave you the diameter of the cylinder, which was 15, so the radius is 7.5 because that's just half the diameter. So you're going to fill in here. You have surface area equals 2 times pi times your radius, which is 7.5 squared, plus 2 times pi times your radius, which is 7.5, times the distance between the two circles, which is 9. We're going to get this in terms of pi first. So when you do, let's evaluate this section right here. You get 112.5 pi plus 135 pi. So in terms of pi, it is 247.5 pi. Okay, so to evaluate that in your calculator, you're just going to say 247.5 times pi using the pi button. And so your approximate answer, there we go. So your approximate answer is going to be 777.54 square meters. Okay, so let's move on to pyramids. Okay, so looking at the pyramids here, I'm looking at the lateral area is just 1/2 times the slant height times the perimeter of the base, and the slant height is the height of the triangles of the pyramid. So if you look at this right here, this triangle on the side, this is L. This is the slant height of the pyramid. It's making a right angle with the side of the base here. That is the slant height. The height of the pyramid is this part right here. Don't confuse the two. Okay, so you have your formula. Surface area equals 1/2 times the slant height times the perimeter. This is just your lateral area right here. All right, plus the area of the base. So your process is still the same. You're finding the lateral area is the same as finding the area of each triangle and adding them to the area of the base. So you're still finding the area of each side of the surface and adding them all together. The formula is just a shortcut to do that. Okay, so the base for this one right here, it's 8 by 8, so this is a square. Okay, so the formula for area is side squared. So we're just going to fill in here. So we have our surface area equals 1/2 times our slant height, which here is 11.7, times the perimeter. Well, this is a square, and each side is 8, so 8 times 4 is 32. Whoops. There we go. Plus a side squared. So your side is 8, so this is 8 squared. Okay, so putting this in the calculator, this first part, you should get 187.2 plus 64, which you probably did not write this down. You probably just put it all in your calculator. This gives you 251.2 square meters. Okay, pause the video and you guys work number 2 and then check back for the right answer. Okay, so looking at number 2. All right, for this one, we don't know what the slant height is. We have the height from the base to the top, but we don't know the slant height, which is the height of this triangle right here, or this triangle right here, or that one, or that one. It's all the same thing. Okay, so what we're going to have to do is we're going to have to draw one. We have to draw a triangle in there. So here's what we're going to do. We already have that part, so I'm just going to come out here. We have that, and then so we're using this 3 right here. It makes a right angle right here. Okay, so we have a right triangle. So we know this side right here is 3. Okay, we know that this is half the distance of the whole the way across. So all the way across is 16, so this part right here has to be 8. Okay, so all we have to do now is find, all we have to do is find the hypotenuse of this triangle, which will be the slant height of that pyramid. Okay, and whenever you're missing a side of a triangle, you can use the Pythagorean theorem. So here you have x squared equals 3 squared plus 8 squared. Okay, well 3 squared is 9, 8 squared is 64. You add those together, you get 73. So you have x squared equals 73. So if you take the square root of both sides, you have that x equals the square root of 73. Remember how I told you guys that this is the most accurate answer, because if you have a decimal, you're just rounding your answer and it's not going to be as accurate. Because we have to plug this back into the problem, we're not going to round this to a decimal right now. We're going to plug it into the problem as the square root of 73 so we can get the most accurate answer. Okay, so I mean, you're going to get a similar answer if you did. I'll show you that in a minute. Okay, so let's plug this in. So we have the surface area is equal to 1/2 times the square root of 73 times the perimeter of the base. Well, the bases are the sides of the base are 16. It's a square. So 16 times 4 is 64. Plus the area of the base, which again is side squared, so 16 squared. Okay, you put all this in your calculator. I'm making lines over. You put this in your calculator, you're going to get 529.41 square feet. Okay, so if while ago you did not use the square root of 73, instead you got the decimal, you would have gotten, well, the decimal was like what, 8.54. which would have given you a surface area of 529.28 square feet. Now it is a little off. I mean, so that's why I said I want you to leave it as the square root of 73 so that you get a more accurate answer. Okay, pause the video and y'all work number 3. Okay, so looking at number 3, all right, I'm going to plug all this in. Okay, so we know that the slant height is 11.3. And the perimeter of this, it's a regular polygon, and they're all 6 sides. So we know that there are 6 sides here at 6 yards apiece. So the perimeter is going to be 36. Right, and I gave you the area of the base here, which is 93.53. So we just need to fill all of that in. So your slant height was 11.3. The perimeter was 36. And the area of the base is 93.53. Okay, you put all of that in your calculator. If you want to break it out, this first part would give you 203.4 plus 93.53. Add those together, and you get 296.93 square yards. Okay, let's move on to cones, the next page of the notes. Okay, so basically for a cone, the lateral area is pi r times the slant height of your cone. Okay, the surface area is pi r squared. This is just the base of this is a circle, so that's the formula for the area of the circle, plus your lateral area, which is just the area of the other sides of the figure. Okay, so all we have to do is fill this in. Okay, so we have, get my pen here. Okay, so we have the surface area equals pi times, well, the radius here is half the diameter. If your diameter is 27, your radius is going to be 13.5. Okay, so you're going to have 13.5 squared plus pi times your radius again, which is 13.5, times the slant height here, which is 32.9. Okay. All right, so looking at this, all you have to do is plug this in. I want to get it in terms of pi first, though, so let's go ahead and do that. All right, so you have 13.5 squared, which is 182.25. You have 182.25 pi, plus, and then you have 13.5 times 32.9, which is 444.15. Pi. Okay, you add these two together and you get 626.4 pi millimeters squared. Okay, so that is in terms of pi. Okay, so now we can go ahead, I'm going to go ahead and say we can do a decimal. So we just round to the nearest hundredth. So if you put this in your calculator using the pi button, your approximate answer is going to be 1,967.89 millimeters squared. Okay, pause the video and you guys work number 2. All right, so for number 2, using your formula here, you have the surface area is equal to pi times the diameter. We don't have the diameter. I'm sorry, the radius. We don't have the diameter either. So we have to figure this out. So again, we're going to use triangles to do so. So all we have to do is we're just going to drop a triangle in here. We have the height of this is 25.2. So I'm just going to draw a triangle here, and I'd have a perfect right triangle right here. If I draw a segment from the center of this cone to the outer edge right here. Okay, so I'm just going to do that. So that means that I have a perfect right triangle right here. Okay, I know that this piece right here is 25.2. I know this is 27.3. I need to know this part up here because that will be my radius, and that's the part I want to know. I'm just going to label it as R. So all I have to do is use the Pythagorean theorem to figure this out. So I have 27.3 squared equals 25.2 squared plus R squared. Okay, so if you subtract 25.2 squared from each side, you get 110.25 equals x squared. Oops, equals x squared. And if you take the square root of this, you actually come out with 10.5, which is 10.5 times 10.5 is 110.25, so that's an accurate answer. So you get that x equals, or r equals 10.5. Okay, so our radius is 10.5. Okay, so let's just go ahead and finish filling in our formula here. So we have 10.5 squared, which we know is going to be 110.25, plus pi times 10.5 times the slant height, which is 27.3. Okay, let's get this in terms of pi first. So when we do, we're going to evaluate this right here, which we just said was 10.25 pi plus 286.65 pi. Add those two together, and you get 396.9 pi. That's inches squared. Oops, show another line. And that is inches squared. All right, so that is in terms of pi. Okay, so stick that in the calculator and use the pi button. Your approximate answer is 1,246.9 inches squared. Okay. All right, so let's talk about parts of a sphere. Okay, so here's your sphere. The diameter is what goes right through the center of the sphere, from the outside edge of the sphere to the other, going through the center, which the center is the very center of the sphere. The radius is the center from to the edge of the sphere. And the great circle basically slices the sphere into two hemispheres. Okay, so half of a sphere is a hemisphere. So let's talk about the surface area of spheres. Okay, so our formula for that is 4 times pi r squared. Now, I know that it seems like you're just going to say you're going to multiply the area of a circle by 4, and that's how you get it, but that's not how that works. There's a whole other process in which it does work. And if you have questions, there's a really cool video that we could watch to figure this out. But I'll let you decide if you want to see that or not. Okay, so let's just use the surface area formula here, 4 pi r squared. All right, so for the first one, it's pretty straightforward. You already have the radius, it's 2.8. So all you have to do is plug this in. All right, so you have your surface area is equal to 4 pi times 2.8 squared. Okay, let's get it in terms of pi first. And when you do, you get 31.36 pi meters squared. Okay, but let's go ahead and get a decimal answer. We'll round to 2 decimal places. So if you plug that in your calculator using the pi button, you get 98.52. Drawing lines again here. All right, so 98.52 square meters. And you pause the video and do number 2. Okay, number 2, you don't have the radius, you just have the diameter, which is 24 millimeters, but to find the radius, you just divide that by 2, so your radius is 12. So all you have to do is plug it in. So you have 4 pi times 12 squared. So in terms of pi, that is going to be 576 pi millimeters squared. Okay, let's go ahead and approximate. So when we do use the pi button, you have 1,809.56 millimeters squared. Okay, let's talk about hemispheres. Hemisphere is half of a sphere, and its surface area is 3 pi r squared. This is why I told you don't think of it as being 4 times the area of a circle, because then you would think hemisphere should be 2 instead of 3, and it doesn't work that way. So the formula for the surface area of a hemisphere is 3 pi r squared. Okay, so look at number 3. We already have the radius. It's 14, so all we have to do is plug in. So we have our surface area equals 3 pi times 14 squared. Go ahead and get it in terms of pi. Okay, so you have, when you do get it in terms of pi, you get 588 pi. And that would be yards squared. Okay, let's get an approximate answer as well. So if you plug that into your calculator, you get 1,847.26 square yards. So 1,847.26 square yards. Okay. All right, so number 4, y'all pause the video and y'all do that one and then check back in for the answer. Okay, we didn't have the radius here, so we have to take the diameter and divide it by 2. So the radius here is 6.1. So all we have to do is plug in our numbers here. We have 3 pi times 6.1 squared. Plug that in. I'm going to get in terms of pi first. All right, so we have 588. I'm sorry, we have 111. My bad. We have 111.63 pi centimeters squared. Let's get an approximate answer as well. So you get 350.70 square centimeters. Okay. All right, let's move on to the last page of notes. Okay, the review. All right, so what I'd like y'all to do is I'd like you to pause it before you work each one of these, see if you get it correct, and then just by checking back in on the video. Okay, but pause the video first and work these by yourself. Okay, so let's look at number 1. Okay, so you have the surface area of a can of soup is what you're trying to find. Well, this shape is a cylinder, so your formula for a cylinder is 2 pi r squared plus 2 pi rh. Okay, so looking at this, I'm just going to fill in here. It was actually, I gave you the surface area, so I'm going to fill in that. So it's 51.84. We're trying to find the height, so h is what we're going to solve for. All right, so we have 2 pi times the, let's see, the diameter is 3 inches, so the radius is 1.5 squared plus 2 pi times 1.5, and we're looking for h. Okay, we're going to leave pi alone right now, and we're just going to leave it as pi for a few minutes, for a couple of steps, and then let's see what we do. We're going to evaluate this first part and leave it as pi. We'll multiply 2 times 0.5, and that will be 3 pi h. Let's look at that. So you have 51, draw lines again. All right, 51.84 equals 2 times 1.5 squared is 4.5. So you have 4.5 pi plus, now I just said 2 times 1.5 is 3, so you have 3 pi h. Okay, so the first thing you're going to do is you are going to subtract 4.5 pi from both sides. My 5 disappeared from over here. I don't know how that happened. Sorry, there we go. All right, so 51.84 minus 4.5 pi, and use the pi button on your calculator, gives you 37.7, and that equals 3 pi h. Okay, so now what you're going to do is you're going to divide both sides by 3 pi. Okay, so that gets rid of it over here. All right, so in your calculator, and you remember how to do the fractions on your calculator. So you go to math, and then you go over, you click the math button, and then you go over to frac for fractions, and you pick the first one, which is n over d, and use that. It's easier to type in if you have a TI-84. Okay, so when you do evaluate this, you get that the height is 4 inches. Okay? All right, pause this and do number 2 if you haven't done so already. Okay, so looking at number 2, you have a box of cereal, which is a rectangular prism. So here's your surface area formula, 2 times the length times the width plus 2 times length times height plus 2 times width times height. Okay, so I'm just going to fill in here. Okay, so we know the surface area, and the surface area is 272. Right, 272, drawing lines again. Okay, so 272 equals 2. We don't know the length, so that's the part we're leaving out. All right, so I'm going to go with the width being 2. I'm going to use the bottom. What I know is the bottom part of this, which you could use whatever you wanted to. I mean, you could have used 12 here too. It doesn't really matter. All right, so I'm going to do 2L plus 2 times 12 times L plus 2 times 2 times 12. And I'm sure you have the same combination somewhere in your formula, even if you didn't use the same length and width as I did. Okay, so looking at this, I'm just going to evaluate a little bit. I'm going to simplify. So I have 272 equals 4L plus 24L plus 48. Okay, I'm going to go ahead and subtract 48 from both sides, and I'm going to add 4L plus 24L, which is 28L. So I get 224 equals, on those lines, okay, 224 equals, now 24L plus 4L is 28L. All right, now I have to divide both sides by 28. So I get the length is going to be 8 inches. Okay. All right, so pause the video and work number 3. Okay, so let's look at number 3. For number 3, you have 2 figures here. You have a cone on top of a cylinder. Okay, so you have a cone without a circle, which is the lateral area, and you have a cylinder with only one base. So in the formula, you're only going to use one circle. So instead of doing 2 times the area of a circle, you're just going to leave out the 2. It's just one circle. It's the one on the bottom, the flat part that's sitting on. Okay, and then we'll add those 2 together to find the total surface area. So let's look at the cone. Now, because you're not using the circle, it's literally just the lateral area. So all you have to do is pi times radius times the slant height. Okay, well, we know that the diameter of this is the same as the diameter down here, which is 34. So half of 34 is 17. So your radius is 17. So let's see. Just fill in here. So you have pi times 17 times 20. We're going to leave this in terms of pi right now. All right, so this is 340 pi. Okay, so I have found the surface area of the part of the cone that's on the outside. Okay, so I am going to go ahead and put that down here by total surface area. I'm going to go ahead and put 340 pi. Okay, then I need to find the surface area of this cylinder minus one of the circles. So I'm just going to use one circle. So I'm going to use pi r squared plus 2 times pi times radius times the height, which remember is the distance between the 2 bases, which are the circles. So looking at this, we have the surface area is equal to pi times your radius, which is 17, squared plus 2, times pi times 17 times 12. Okay, so I'm going to leave this in terms of pi as well. So when I put that in my calculator, 17 squared, I get 289 pi plus 2 times 17 times 12 is 408 pi. I'm going to add those 2 together, and you get 697 pi. So that is my surface area for the cylinder. So I'm going to come down here and put this on my total surface area. All right, so I've already got 340 pi for the cone, and now I have 697 pi for the cylinder. I'm going to go ahead and add these 2 together. I'm going to leave it in terms of pi first. Okay, so that's going to be 1,037 pi, and this is meters squared. I will go ahead and get an approximate one too. We'll do it to 2 decimal places, so put that in your calculator, and you end up with 3,257.83 meters squared. Okay. All right, pause the video and y'all do number 4, and then we'll talk about it. Okay, so looking at number 4, all right, you have a cone on top of a hemisphere, but you don't have the circle of the cone or of the hemisphere to put on the surface area. Okay, so looking at this, whoops, my page just jumped, I'm sorry. So looking at this, all right, we have a cone without a circle, which is just a lateral area, and you have the hemisphere without the circle. So after you do this, you're going to subtract the area of after you find the surface area of the hemisphere, you're going to subtract the area of the great circle from that. Okay, so looking at this, we have the lateral area of the cone, which is all we need to find, so we don't need the circle part. Okay, so the radius of this, we know the diameter is 9, so the radius is 4.5 because that's half of 9. So I'm just going to fill in. So you have the lateral area is pi times your radius, which is 4.5, times the slant height, which is 13. We're going to leave this in terms of pi, and we get 58.5 pi. Okay, so I'm going to come down here on total surface area and go ahead and plug that in because I'm going to have to add all these surface areas together, right? So one of these is going to be 58.5 pi. Okay, so let's get back up here and look at the hemisphere. Formula for the surface area of a hemisphere is 3 pi r squared. So I'm going to plug this in. We have the surface area equals 3 pi, your radius is 4.5 squared. I'm going to leave this in terms of pi. So this is 60.75 pi. Now before I put that down there for my total surface area, I've got to get rid of the great circle. So we're going to subtract the great circle area from the 60.75. So let's find the area of the great circle. Area of a circle is pi r squared. We know our radius is 4.5, so we just have to plug in. Okay, so we have the area equals pi times 4.5 squared. We're going to leave this in terms of pi. So this is 20. Why am I drawing surface lines again? Okay, so this is 20.25 pi. Now what we're going to do is we're going to take the surface area of the hemisphere, and because it's without the circle, the surface area needs to be without the circle because it's not showing on the outside. We're going to subtract the area of the great circle from this. So we're going to take 60.75 pi and subtract 20.25 pi. Okay, so I'm going to do that over here. Let's see. Okay, so I have 60.75 pi minus 20.25 pi. Okay, and that gives me 40.5 pi. So the surface area showing on that hemisphere is 40.5 pi. Okay, so I'm going to come down here for my total surface area, and that's what I'm going to put in right here. We have 40, drawing lines yet again, 40.5 pi. So if I add these together, right, what I end up getting, let's scroll down. Okay, what I end up getting, I'm going to do terms of pi first, is 99 pi. So I get 99 pi meters squared. Right, we can go ahead and get our approximate answer here. The 2 decimal places, we get 311.02 meters squared. Okay. All right, please let me know if you have any questions, and I will catch you on the next video. Thank you.